Okay, this is the Module 4 review for Math 990. So we're just going to look at a few problems throughout. First, I want to look at this one where we're looking at these three graphs and deciding, are they dependent, which means there's infinitely many solutions? Are they independent and consistent, which means one solution? Or inconsistent, which means no solution? When I see dependent, that means the line is the lines are dependent on each other if there's infinitely many. And so that's going to be B, where it's just basically one line on top of another. So they're dependent on each other the whole time. Independent and consistent is one solution, and that's going to be A, where they're independent of each other, but they do cross at the one point. And then inconsistent is where they don't cross. So the only way lines don't cross, what kind of lines do those have to be? Well, those would have to be parallel lines. Okay, so it can help just understanding this whole module to understand that topic of these three different types that we have: the independent and consistent, where we have one solution; the dependent, where we have infinite solutions; and the inconsistent, where we have no solution. Okay. Let's look at number 2. So number 2, the first thing we're going to do is we're going to graph both of these lines. Okay, so I'm just going to look at the lines first, like y equals negative 2x plus 1, and then the other one like 2x minus y equals negative 5. So to graph this one, we can see it's in y equals mx plus b form. And so I'm just going to find the slope, which in this case is negative 2. The y-intercept would be 1, because remember we're using the y equals mx plus b form, where m is the slope, b is the y-intercept. So anytime it's solved for y, I always graph it like this. So we first find the y-intercept, which is at 1. Next, we use our slope, which is negative 2. We can make it negative 2 over 1. So we go down 2 over 1, down 2 over 1, and you can even go up 2 as long as you go left 1. So you just have to make sure you're going negative just one direction. So up 2, left 1 also works. Okay, now that we have the points, I'm going to look back to the original inequality. Notice it's got an equal sign underneath. So since it's greater than or equal to, that equal makes it have a solid line. So it's not going to be the straightest, we'll do our best. Okay, so we've got our line, and then we need to shade this line. So when we shade it, I like to do a test point. Since it doesn't cross through the point 0, 0, I will choose that one. So let's plug in 0, 0. We get 0 is, and this is where you do need to use the inequality, 0 is greater than or equal to negative 2 times 0 plus 1. So 0 ends up just being greater than or equal to 1. Is that true? Well, no, 0 is not greater than 1, and so the side we would shade would be this. Now when I'm doing it this way, especially if you're drawing it on paper, I'll just do lines like that, just like one direction. I don't want to go crazy shading, because I know we're going to have to figure out where they're both shaded. So I just kind of want to mark it so that I remember. Okay, so that inequality is done. Let's do this other one. So we can either solve for y, or we can find the x and the y-intercept. I think I'm just going to find points for this one. I think that seems easier, but you can do it the other way if you'd like. So I'm for sure going to do 0 for x, and then I might just do like 2 for x, because I know if I do 0 for y, 5 doesn't divide evenly by 2, and this graph might not let me graph like a half point, although it might. So we can do that one too. We'll just see what it looks like. Okay, so if we put in 0 for x, we have 2 times 0 minus y equals negative 5. So 2 times 0 is gone. Now we have negative y equals negative 5. Well, we want y, so we have to, remember there's a 1 in front there, so we'll need to divide both sides by negative 1, and we get y equals 5. So y equals 5, we've got 1 point. let's go ahead and do 2 for x now. 2 times 2 minus y equals -5. So that'll be 4. I'm going to do this, skip a couple steps because I'm almost out of room down there. I guess I can use this over here too. So then I get those cancel. I get -y equals -9. Again, we divide by -1 and y equals 9. I would recommend doing this where you can spread out a little bit because that makes me nervous. Like, did we make a mistake there? So it's always good. Give yourself space to spread out your work. If you get stuck like this, get yourself a new piece of paper. Okay. So, okay. So we could do one more point, and sometimes that's a good idea just to make sure everything looks right. So let's go ahead and do 0 for y. So we'll have 2x minus 0 equals -5. So 2x equals -5, divide by 2. So x equals -5/2, or -2.5 or -2.5. Since this is just for your notes, you can just write it how you're comfortable with. Okay, so let's graph that and see what we've got. So we've got a point at 0, 5. We've got a point at 2, 9. And we've got a point at -2.50. Do those three look like they line up? I think yes. I think they do look like they line up. Oh, almost made a mistake. Hopefully you guys caught me as I was starting to draw that line. Why was that a mistake? Well, we need to check back. So that is the line, but we need to check back and make sure we're graphing it correctly. Since this does not have an equal sign, what does that mean? Well, it means instead we're going to have a dotted line. Oops. Through. Okay. So lastly, we need to, let me just erase some here so I have a little space to work with. Lastly, we need to figure out where are we going to shade that part? Well, let's do again a test point. It doesn't pass through the point 0, 0, so we're going to test that. We have 2 times 0 minus 0 is greater than -5. So basically 0 is greater than -5. Is that true? Well, yes it is. 0 is greater than -5, and so we'll shade this area where 0, 0 is. Okay, let me switch colors here. It'll be helpful. Oops, doesn't want to let me off. There we go. So now the final shading is the place where they both exist. So what's nice is because we did the lines, you can kind of see these X's. So we can see the place they're both shaded is right here. So when you give your final answer, especially if you're doing written work, make sure you only shade this final area. So the final solution is only the place where both of these lines are shaded. Okay, let's look at this problem. This is one, it's a little problem, but it can feel difficult. So if x is greater than or equal to -1, that's basically x equals -1. It does have the equal sign, so we're going to have a solid line just through where x is -1, like that. Okay, y is greater than -4. Notice there's no equal sign, so in this one we're going to go through where y equals -4, but just a dotted line right there. Okay, now let's do test points. So 0 is greater than -1. Is that true? Is 0, we're just testing that point 0, 0. Is 0 greater than or equal to -1? Well, yes it is, and so we can see this will be shaded on this side. Okay, on this one, 0 is greater than -4. Is that true? Well, yes it is. 0 is greater than -4, and so we'll be shading above the line. So our final solution will just be in that quadrant. So you do it really similarly. You're just going to graph each line, do your test point, and make sure you shade correctly. And also be careful with dotted or solid. It can be easy to skip that step, but make sure you pause for a second and do those. Figure those out, dotted or solid. Okay, we're actually not going to do question 4, but I just want you to look at it. This one you're supposed to solve with the addition method. And the goal with the addition method is you want to get 2 terms from each equation to be the same but opposite, just like we have here. So we have a plus 6y and a minus 6y. Well, what happens when we add those two together? They will cancel each other out. Positive 6y minus 6y becomes 0. Not 0y, just 0. And so this would end up, when we add the rest of this together, we'd get 8x equals 9. So that's what the goal is with the addition method. And for this exact reason, we want two terms to cancel so that we can solve for that remaining variable. So let's look at another one where it's not quite so easy. So we have on this one 2x minus 6y equals 1 and negative 5x plus 15y equals 3. So we want to get these the same but opposite. So what we need to do is we're basically trying to find their least common multiple. What's the smallest number either 2 and negative 5 will add to be, or 6 and 15? Well, I'm thinking just so we don't get quite so big, although it might not matter. But let's go with the 2 and the negative 5. I'm thinking 10. Their least common multiple would be 10. So we're going to try to get them both to be 10. So here, I'm going to multiply every single number by 5 because that will get this x term to be 10. So we multiply throughout the whole thing. We're going to get 10x minus 30y equals 5. Okay, negative 5x I also need to be 10, but it's perfect. I need it to be a negative 10 so they cancel. So I'm just going to multiply by 2. And again, every single term in this equation. So 2 times negative 5x, I get negative 10x. 2 times 15 is plus 30y equals 6. Do you guys see anything funny happening here? So let's add the equations together. Notice our two terms ended up being the same but opposite. So positive 10, negative 10. We also have negative 30 and positive 30. So when we add these together, those are going to cancel and those are going to be canceled. I'm not left with x. I'm not left with y. I am left with 0. Everything was eliminated. So don't make the mistake of thinking there's something left. They're completely eliminated. Now we need to add these end terms so they equal 5 plus 6 or 11. Now, does 0 equal 11? Well, no, it does not. So since they're not equal, this would be no solution. Okay, so let's say it came out, so totally different equation, it came out to be 5 equals 5. What would that be? Well, that would be infinite solutions, because they're going to have an infinite number of ordered pairs. So basically, if we graphed these two lines, we would get something like this. We'd get a set of parallel lines that never cross. So they have the same slopes, but they never cross. And that's why there's no solution, because those lines don't cross. Now on this one, if we graphed this hypothetical one down here that we talked about that became 5 equals 5, the line would just be a line and then another line right on top of it. And so that's why it's infinite solutions when it's the same number, okay? But for this number 5 that we were doing, it came out to 0 equals 11, which is not true, which is no solution, which on a graph would look like that. Hopefully those problems are helpful. I will make another video and hopefully you can check that out too.